Today we'll look at buoyancy for the special case of floating bodies. So in this case, buoyancy is effectively the force that keeps a body floating on the surface of a fluid. So in other words, if we take a free body of this block floating in the water, then what we have is a force of weight that's pushing down on this object. So this is due to gravity. And we have a buoyant force, which in other words is called buoyancy, that acts at the center of the volume of displaced fluid. Okay, so this is what we call the buoyant force, or FB. Now, in accordance with Archimedes' principle, the magnitude of the buoyant force is equal to the weight of the displaced fluid. So you can imagine that when this block is placed in the water, then a volume of fluid is going to get displaced. Okay, so this block is really three-dimensional. And this here is the volume of the displaced fluid in 3D. Okay, and the weight of this displaced fluid is effectively the density of the fluid by the submerged volume. So this is the volume of the part of the object that's below the water, and multiplied by gravity. So that's Archimedes' principle. And this force acts at the center of buoyancy. So that's at the center of the volume of the displaced fluid in 3 dimensions. Now if we apply Newton's first law, so sum the forces in the vertical direction, well, when the object is floating, the net force acting on the object is 0. And therefore, the force of weight is equal to the buoyant force. Multiplied by the gravitational acceleration. So I'm just going to take the density of the object or the block, multiplied by the volume of the object, multiplied by gravity, is equal to the buoyant force. So that would be the density of the fluid by the submerged volume, multiplied by gravity. And if we cancel out the gravitational acceleration, we have the density of the object on the density of the fluid is equal to the submerged volume over the volume of the object. So this tells us that if the density of the object is less than the density of the fluid, so this implies that the submerged volume is less than the volume of the object, which means that the object floats. Okay, so as you can see, if Vs is less than V0, so effectively only part of the object is submerged, and the object basically floats. And for example, if the density of the object is equal to 1/4 of the density of the fluid, so that gives us on the left hand side 1/4 is equal to the submerged volume on the volume of the object, and therefore the submerged volume is equal to 1/4 of the volume of the object. So this tells us that 1/4 of the object is submerged. Okay, so if the ratio of the density of the object to the fluid is equal to 1/4, then 1/4 of the volume is underwater. And I'll see you in the next video.